good day. Welcome to our video presentation. Today, we'll delving into the world of apportionment, specifically focusing on the Jefferson method. So Ms. Acebes will introduce to you our learning objective for today's discussion.
Here are our learning objectives. So first, define essential terms related to Jefferson's method. Second, be able to outline the step-by-step process involved in applying Jefferson's method. Third, apply Jefferson's method to real-world or hypothetical population data to determine seat distribution.
So now, for our introduction, we will explore about the Jefferson's method. It is a technique used in apportionment to fairly distribute seats in a legislative body based on population. So this method developed by Thomas Jefferson. So he was the first apportionment method used in the United States. But by the end of this lesson, you will understand how it works and how to apply it using real-world problems or examples. For our description, Jefferson's method differs from Hamilton's method on how to resolve the situation when the lower quota or initial quota is less than the actual seats available, which is referred to as modified lower quota. So Jefferson's method tends to favor larger states. And if a state or group DAO gets more than the integer immediately above its quota, so Jefferson violates the upper quota rule. So this method was proposed by Thomas Jefferson in 1792, and he was the first used in U.S. Congress in 1792 until 1840. So he is the one of the founding father of U.S. and became its third president.
Definition of terms. So these are the key terms related to Jefferson's method. So first, number one, we have the Jefferson's method. It also known as the Jefferson's method of apportionment. It is a mathematical technique used to allocate seats in a legislative body based on population or other relevant criteria. So it is one of the several methods of apportionment and seek to distribute a fixed number of seats among different groups fairly. Number two is the apportionment. So it is the process of distributing a fixed number of items among various groups based on a certain criteria such as the population. Number three, we have the quota. It is the ideal number of seats the group should receive based on its proportion of the total population. It is calculated by dividing the total population by the number of seats to be distributed. Number four, we have the divisor. It is a number used to divide the total population of each group to determine how many seats each group should receive. So in Jefferson's method, it is a modified divisor that is applied iteratively to arrive at the final apportionment. Now, for number five, we have the lower quota. It is the greatest whole number less than or equal to a group's quota, and in Jefferson's method, groups may initially receive seats equal to their lower quotas. And for number six, we have the adjusted divisor. So the divisor that is adjusted downwards to ensure that the total number of the seats allocated does not exceed the available number of seats. Number seven, we have the seat allocation. It is the final distribution of seats to each group based on the adjusted quotas calculated through the Jefferson's method. And lastly, number eight, we have the standard quota. So it is a calculated value representing the exact number of seats each party or group should receive based on the share of their total population or votes relative to the total number of seats available.
Steps and procedures in using the Jefferson's method. So first, you have to solve for the standard divisor, and then you have to determine the standard quota for each group by dividing its population by the standard divisor. Round each group's standard quota down to the nearest whole number. This is called modified lower quota. Choose a number m which represents a desired approximate size for congressional districts. And then you have to compute the modified quotas for each group and round these numbers down to obtain Q. If Q1 plus Q2 plus ... plus Qn is equals to Q, and then we have the apportionment. Otherwise, change m and try it again. The divisor we end up using is called a modified divisor or adjusted divisor.
So for you guys to have further knowledge about Jefferson's method, here are some sample problems we've created. A country is distributing 10 seats in a legislature among 4 states based on their population. State A has 450,000 population. State B has 300,000 population. State C has 150,000 population. And State D has 100,000 population. The total population is 1 million people.
Solution for problem number 1. Step 1. Find the standard divisor. The total population is 1 million people. The total number of seats is 10. We calculate the standard divisor by dividing 1 million divided by 10 equals 100,000. This means each seats represent 100,000 people. Step 2. Calculate the standard quota. Now we divide each state population by the standard divisor. State A is 450,000 divided by 100,000 equals 4.5. State B is 300,000 divided by 100,000 equals 3.0. State C is 150,000 divided by 100,000 equals 1.5. State D is 100,000 divided by 100,000 equals 1.0. Step 3 is find the lower quota. We take the whole number parts of each standard quota. State A 4.5 to 4, State B 3.0 to 3, State C 1.5 to 1, State D is 1.0 to 1. Now we add them up. 4 plus 3 plus 1 plus 1 equals 9. Step 4 is to adjust the divisor. The total should be 10, but we only have 9 seats. To fix this, we lower the divisor from 100,000 to 90,000 and recalculate. State A, 450,000 divided by 90,000 equals 5.0. State B, 300,000 divided by 90,000 equals 3.3. State C, 150,000 divided by 90,000 equals 1.6. State D, 100,000 divided by 90,000 equals 1.1. Step 5, final apportionment. Now we round again. State A gets 5 seats. State B gets 3 seats. State C gets 1 seat. And State D gets 1 seat. The total number of seats is 10.
Here comes another sample problem. A company is assigning 12 scholarships to 4 schools based on the student population. School X has 1,200 student population. School Y has 600 student population. School Z has 400 student population. School W has 200 student population. The total student population is 2,400 students.
So for the interpretation, for the question number 1 is the country is allocating 10 legislative seats among 4 states based on their populations. Ensuring fair representation, first is the standard divisor is found by dividing the total population, which is 1 million, by the total seats of 10, resulting in 100,000 people per seat. So each state's standard quota is then calculated by dividing its population by the divisor. But rounding down the quotas leaves only 9 seats assigned. To adjust for this, the divisor is lowered to 90,000, allowing for recalculated quotas that distribute all 10 seats accurately. So this method ensures proportional representation while slightly favoring larger states. For the question number 2, the company is distributing 12 scholarships among 4 schools based on their student population. To determine fair allocation, the standard divisor is calculated by dividing the total population, which is 2,400, by the total scholarships of 12, resulting in 200 students per scholarship. So each school's population is then divided by this divisor, yielding quotas of 6, 3, 2, and 1 for schools X, Y, Z, and W, respectively. Since all quotas are whole number, there is no adjustments needed, and the final scholarship distribution remains X equals to 6, Y equals to 3, Z equals to 2, and W equals to 1. So this ensures a proportional and straightforward allocation without requiring modifications to the divisor.
Conclusion about Jefferson's method. Jefferson's method of apportionment is a historical approach used to distribute legislative seats among states based on their populations. It follows a divisor method where the total population is divided by the number of available seats to determine a standard divisor. Each state's population is then divided by this divisor to find its initial quota. Unlike conventional rounding, Jefferson's method always rounds down the quotas to the nearest whole number. If the total number of assigned seats is less than required, the divisor is slightly decreased, and the process is repeated until all seats are allocated. This method, while effective, systematically favored larger states by giving them a greater share of representation. Due to concerns about fairness, it was eventually replaced by more balanced apportionment methods such as Webster's and Huntington Hill's. Nevertheless, Jefferson's method played a significant role in the development of proportional representation and democratic systems.
So here are our references. Thank you for listening and God bless.